This is 6.2, radicals and rational exponents. So the nth root of a would be written as b to the nth power equals a, and I would rewrite it in radical form, where the exponent becomes the index, the number inside the square root symbol, and the answer, a, would be on the inside. So if I take the nth root of a, that equals b. I can rewrite this with numbers. It makes it a little easier to understand. So 7 squared would be 49. If I take the square root of 49, that's 7. If we have no number as the index in the radical, it means that we are taking the square root. So I don't have to write this number here because it's a 2. So it would be an invisible 2 automatically if there's no number written in there. So radicals can be written as exponents. Here, I would have the square root of a, and I would rewrite that as a to the 1/2 power. There's nothing here as the index, so I know that it's an invisible 2, so that's 1/2. Cubed root of a would be a to the 1/3 power. So whatever number is this index, that would be the bottom, the denominator, of the fraction exponent. And as it's written as a fraction exponent, we'd call that rational exponent form. Rational means that we can write it as a fraction. Exponent, we know that. So fraction exponent form. Rational exponent here. Easy way to remember that, the root, like roots of trees, are in the ground. So that's down below. And so the root stays like the roots of a tree down below. So we're going to rewrite in rational exponent form. The cubed root of 125, that would be written as 125 to the 1/3 power. The 7th root of 329 is 329 to the 1/7 power. Real nth roots of a, so we can figure those out. If n is some integer greater than 1, so that would be like 1, 2, 3, any whole number like that, and a is any real number. If n is odd, so we have an odd index, a has one real root, the nth root of a, or a to the 1 over nth power, we'd get one answer. Cubed root of 125, so odd index, I get my answer is 5. If n is even, and it's greater than 0, we have two real roots, the positive and negative answers of the nth root of a. So if I take the square root of 100, even index because it's a 2, I could have 10 squared is 100, so 10 times 10 makes 100, and I can have negative 10 times negative 10. Negative times a negative is a positive, so I still get a positive 100. So I know the answer is plus or minus 10. So I have two numbers here, positive 10 and negative 10. If n is even and a is 0, we get one real root. Nth root of 0 is 0. And if n is even and a is negative, so a is less than 0, we get no real roots. It does not make sense to have something times itself to make a negative number. So what times itself makes negative 4? Well, 2 times 2 is positive 4. Negative 2 times negative 2, still positive 4. But I can't have positive 2 times negative 2 to make the, because those aren't the exact same number. So it doesn't make any sense. So we would say that's no real roots, no real answers. So let's find the indicated nth root of a. So given when n is 3 and a is 64, we're going to rewrite as in radical form the cubed root of 64. So I'm looking for a number times itself 3 times to be 64. If I try 2, 2 times 2 is 4, times 2 is 8. That doesn't work. So if you keep going and you try it, you'll get 4. 4 to the 3rd power is 64. Now if I try the 4th root of 625, I would rewrite that as the 4th root of 625 this way. And if you try the numbers, what times itself 4 times makes that, you would get positive 5 or negative 5. We know that we have plus or minus because the index is even.